Hello, hi, and this is Sujit Christy yet again with a very special guest today, a fireside chat, which is going to involve software engineering. So our conversation is going to revolve around what is software engineering and how do we marry engineering and cyber safety, right? So that would be the nucleus of the conversation. And to have this conversation, I have a very special guest and a good friend of mine, uh, Benjamin Luck. He calls himself a cybersecurity combatant. And where we both connect is that he's also a CISSP, a member of the IC Squad elite club, I would call it. And he's also a licensed private investigator. So I am very intrigued to have this conversation. There's a lot we're going to talk about software, testing, safety, and of course, engineering. And before I bring him in, I'd also like to tell you that he's been working on a very interesting piece of work with respect to industrial systems and cybersecurity. So very soon he would be publishing an article in one of the most reputed journal, and I'm looking forward to reading it. So Ben, thank you for making time to have this conversation with me today. How are you today?
Good to you. Thank you for having me on today. It's good morning to you and afternoon over here.
That's right. The best thing is technology has enabled us to connect anytime, anywhere, to have an interesting conversation. So driving straight in, Ben, I just would like you to talk about safety. Because typically we talk about, we use the word safety when we use gadgets, or especially in terms of automobiles. Right? Everything in automobile is built around safety. But usually software, we don't talk about safety. That's the reality, and that's the truth. But today, technology is being used in automobiles, for example, right? And I'm sure it's used in aviation, it's used in ships. And as we have this conversation, we're also hearing about a disaster in the US, the Baltimore Bridge disaster, where the ship's electrical systems have failed. So there's a lot to be uncovered, right? So I'd like you to set the context. What is safety in engineering process?
Yeah, so I guess talking about engineering in general. So the engineering itself, is quite a broad field, and this includes like chemical engineers, mechanical engineering, software engineering, electrical engineering. So it's quite a broad field in its own right. But one of the core requirements and things that need to be looked at in engineering often is safety engineering. Because it's engineering itself dates back before we started thinking about cybersecurity. So it's engineering goes back when we first started making airplanes, first started making cars, first started making architecture in certain buildings. So and the idea of cybersecurity didn't exist, but safety was a very important part. And you can see things like that in everyday things used today, like cars. It's like cars have to be built to certain standards. Aircraft have to be built to certain standards, and these are engineers that look at these standards or guidelines to implement that. So, as an engineer, you would engineers will, I guess, they bring the imagination to life in a sense. So they help. They will get a new idea, a new design, a new thought, or new technology, and apply that into society that we can use it in a method. But we need to make sure those are safe, because people using it. We need to make sure that people don't come to harm. And so that's part of safety engineering. So engineers will go through certain processes where, they will look at, in engineering terms, it's called a hazard. So, you go, well, a hazard is something where a potential of harm could happen. And then you may have a failure, which is kind of the realization of that hazard. And that's when, something goes wrong. And engineers will use certain methods to figure out these hazards and failures and what impact they could have in that harm. Which using safety analysis tables or fault trees. So they've got this sort of hazards, failure, harm sort of mentality. And I guess that's, as things have progressed, there's standards and guidelines that come from that. So, for example, in cars you mentioned, so there's the ISO 26262. So in cyber, we know all that ISOs, but we know there's a lot of them, and there's one particularly to safety in engineering. And same with aircraft. There's like the DO 178B and C, which actually particularly focus on software and programming itself in regards to the engineering process. So there's, and that talks about things like documentation, code standards, testing, looking at the problems of hazards and what controls are put in place to make sure things work right. And that's an important development in engineering. And when I say when things work right and people think safety, they're thinking that's, well, we want to make sure that if something happens, something will fail in a safe state, or will, if your car has a failure, it will want to be in a position where it wants to stop but not accelerate. So these particular ideas where there's built safety in that process. And so this is where software engineers come into things, I guess. So you had engineering, and then when we've had computers come into the world of engineering, yet again, engineers want to implement newest technologies and bring them to life in things that we can use. Software engineers kind of take that engineering process and bring it to the world of software. So, and part of that is that testing, coding, safety, risk sort of mentality. So yeah, that's where I guess engineering processes come along, and why we have safety engineering, and where software engineering starts to come into that.
That's a good overview, Ben, right? But while you were talking, a couple of things were going through my mind. One of them was the movie Speed.
Yep.
Yep, we're talking about industrial systems in the West, sure, right? So how those controls are being, manipulated and tampered with, right? And I think I was just listening to the news, and even the Backlemore Bridge incident, they're saying that the communication, the GPS links were not secure, right? So that, let's leave that aside for a moment. And then both of us travel around the world very frequently, and one of the best ways to get there quickly is the aircrafts, right? So we have the civilian aircraft, and then you have the fighter jets, right? Now, when you were telling me about the automobiles, right, we're talking about fail-safe. How would the engineers look at, ensuring safety mid-air, right? Sometimes you may have to patch them while in motion, right? An emergency patch, right? So I'm just going to get you to relate the context I gave you and tell us, how does cybersecurity come into this context?
Okay. So yeah, so that's a very interesting thing. So I guess generally in the realms of engineering and software engineering, often there wasn't much of a need for actually patching for most ideas. Like, most things were considered safe unless something was realized, and then they would like do a fault analysis and go, well, or root cause analysis and be able to fix something. So you'll probably find that would happen with that ship that's lost power. They'd go and do a root cause analysis and do like a fault tree analysis of that and try and figure out an engineering level what went on. And that would then generate I guess some changes to the system or looking at that. So that's looking at the safety idea of things. And I guess when it's come to cybersecurity, things are much more dynamic. As we can see just recently with a particular Linux vulnerability for an compression system that just happened. And everyone's racing around trying to figure out how we're going to deal with this. But yeah, so I guess this is the interesting thing where we've had software engineering and it's come along, and then in the meantime, we've had cybersecurity come along after software engineering. And software engineering goes back to even the NASA days, putting spacecraft on the moon. So you had software engineers programming at that point, but you couldn't really say that during the 60s or 70s there was any such thing as really a cybersecurity movement. So it wasn't really a culture. So now we've had the cybersecurity come along, and particularly hasn't, as far as my experience anyway, in the industry, hasn't become seriously mainstream until probably the 2000s, where courses started appearing for them. People started considering it more. So cybersecurity was considered more than just something that university students do for fun. So now we sort of had the industry come along, and I guess now this is where it's interesting, where we need to somehow start bringing these two sort of disciplines together. We do have a little bit of a bridge. There's computer scientists, so they mainly just deal with information processing systems and programming computers, and they are starting to move toward that cybersecurity view of things. Engineering processing, we're still getting through that process at the moment and seeing how that can be integrated. So I guess when it comes to you're talking about patching and getting fixes done, or making sure that our aircraft are not only safe, but also in regards to failure, and a failure that may be caused by a cyber incident.
Mm-hmm.
How do we make sure that the system is cyber safe? So I guess this is the interesting pivot when we start looking at, well, why does it matter? I guess, and it matters because all our systems are coming converged. We've got convergence in our systems. Things that weren't either programmed or connected to the internet or incredibly complex. Engineers are having to deal with more of systems that are systems within systems, where a mechanical engineer might have a device that a software engineer has programmed, which then connects to IT infrastructure. And all of a sudden, you've got this chain of devices which are interreliant on each other, and whether directly or indirectly can be affected or have a fault caused by a cyber incident.
Then I have a question. I've been trying to find the answer. Now, we started the conversation. We said, we talked about safety, and we said products are built with safety as a core. But almost 20 years since cybersecurity has been a mainstream conversation, and today it's headlines. And every day or every hour, you have some cybersecurity flash news appearing in several medias across the world. But when I personally look around and look at organizations, they do talk about digital transformation, and all of them are centered around software. But the software engineers do not think security. In other words, secure by design is not their priority. Their objective is to make it work. Is that a human weakness or what is it? I mean, what is your reading about this?
Okay. Well, I guess there's a couple of things that become problematic and need addressing or looking at or improving. And it comes from both sides, not only engineers but also cybersecurity people. So this is a dualistic issue that's we need to sort of look at addressing. Um, I guess let's from a historical point of view, engineers, yeah, they've always focused on safety. So engineers will start having to learn extra skill sets. So this is something whether you're an existing engineer or you're looking at engineering courses. I was talking to a software engineer the other week, and I was particularly discussing with him and asking him, so in your courses, I said, do you have any core units or elective units that cover cybersecurity in your software engineering? And he flat out answered no. so so you can start seeing that. He did mention that in computer science there are some, but software engineering is just it's not a particular thing. And software engineers do have a lot to cover. So unlike a normal program developer, they're thinking that they're being taught electronics, electrical engineering. They're being taught how all this goes together. So they're a little bit more sort of larger picture. So cybersecurity becomes yet again a little bit of an information overload, I think, component when it comes to software engineers. And that's where there probably is some room for development in that area. So same on the cybersecurity end. Um, um, there's been probably a few times, and this probably happens to even just application developers and programmers, and you've probably had the same experience where you've had someone working on something for weeks and they've got this program or as a software engineer, they've built this system that's really great and it's really safe. And then it's like a work of art for them. And the cybersecurity person comes along and just picks a whole lot of holes in it. and so I'm sure, do you have had any experiences as such or?
Oh yeah, every time. So I would say, I mean, I've in my last 20 years, I've never given a clean report in the first round of assessment. Right. So we at least pick one hole. And that one hole is like a cobweb, you can navigate through that and reach the four systems. On the same line, I mean, I just want to extend this, Ben. Today we're talking about AI. AI is the buzzword in every conversation, right? Whether people know about it or people who do not know about it, everybody is talking about it. And at the end of the day, there is a dependency on the software. And we are also talking about biases. So how do we build safety around the AI systems? Or how do we ensure people who use these products and services are safe?
Yeah, so AI has its own challenges, as you're mentioning, and is a bit of a buzzword. So buzzwords never help with solving problems, and often gives people false sense of views and ideas of things. But when it comes to AI particularly, and actually software engineers are in a interesting space where they can actually help a lot with this. Just due to the fact that software engineers are very program orientated, and also to have a good understanding of often of data sciences, which AI is quite focused around. So in regards to a software engineer, AI, is a great idea for looking at doing I guess your backseat driver, making sure that things are safe and stay safe and become an impartial sort of viewer into that. Because one problem with safety is people's bias. So or laziness or there's often a lot of human factors that can make a hazard into a fault which causes harm.
So in essence, what we are seeing is, in addition to a co-pilot, we need a backseat driver as well.
Yeah, that's right. Just making sure we're doing the right thing and
Absolutely.
Well, yeah, it's a very famous and really horrible disaster that happened. That's where someone was ignoring, good advice, with Chernobyl. So you can see where, AI could help, in places where someone needs, good feedback for any partial sets. And same with cybersecurity. Cybersecurity also does, benefit from AI in that regards as well. Um, what the magic thing will be to do is to combine AI with safety and cybersecurity in the way that might be monitoring systems. And to be able to do that effectively, we need AI developers that understand the safety engineering component and the cybersecurity component at the same time to be able to understand what data sets we need, what features do we from the data set should we be looking at to process that into our models to then have outcomes of when something is not considered safe or something is, or a cyber issue is possibly occurring, and be that second check to make sure that's we'll look at ourselves and go, oh, hang on, I'm not too sure. AI can come along and be that's co-pilot or backseat driver.
Absolutely. Absolutely. So what I actually was trying to, interpret whatever you were saying is that irrespective whether you are a software engineer or an AI developer, or you can be developing any product, but cybersecurity is something which needs to be part of that whole process. It cannot be an afterthought. So I guess IC2 has thought this through, and they have introduced the CC program, which is certified in cybersecurity, which allows anyone to acquire this certification and gain that basic knowledge, understanding as to how cybersecurity would help build a safe product. Do you want to comment on that, Ben? Because you're also a CC holder.
Well, actually, I do know some software engineers that are trying to do the CC at the moment. So this is something that actually is a great way for engineers to start thinking about cybersecurity and starting at the beginning level and thinking not only in the development cycle, so you're sort of putting that sec into your DevSecOps when you're doing development of software products. So getting that security design in first and part of the system. But also too, the engineering way of thinking, how do we make sure this all comes into their governance and how this passes through the whole process as well. So it's from both a governance high level and a DevSecOps or SecDevOps beginning process level when we're actually making the product.
So Ben,
And
I'm sorry, I'm just going to interrupt you and I'm going to ask you, right? I mean, you did mention about DevOps, DevSecOps, and then I keep hearing this word shift left. Maybe for the benefit of those people who are going to be watching this conversation, do you want to tell why it is important to think on those lines of shift left, DevSecOps?
yeah, well, yeah, I guess well, I guess in regards to let's say look at DevSecOps. It's like essentially it's almost feels like cybersecurity. When we've looked at that point, it's almost a little bit of a bolt-on. It's sort of like we've kind of come after the fact and go, oh, we've got this whole DevSecOps process, and somehow how can we put a bit of cybersecurity into there somewhere into that particular flow between CI/CD and release and have some sort of code checks and auditing and processes. Sec DevOps, we're starting to get ahead of the game. We're starting to get those processes, right in at the beginning level of even at the feasibility end of things. Before we even walk into the whole DevSecOps process, Sec DevOps process. So it becomes from the beginning to the whole end process. And implementing more automation into that process. So things like SonarQube and so forth, and trying to get developers to use that more as part of the process. Trying to be more security orientated in our risk assessments and how we're doing our processes. So I guess it's a more let's shift forward thinking idea that it needs to become a central part of the whole process. Same way engineers think about safety. Safety is primary. It's you don't even start talking about building a car or an aircraft unless you have that safety conversation first, and you won't even get it through certification if you don't have that safety conversation. And the same will be happening in a DevOps world. You'll start a product if you don't have this conversation and have this idea all the way through. You're going to have a problem, and you're going to come out the other end where you've got the moments governments and Australian governments looking at this, where things have to be secure by design. So if you get the other end of that process and you haven't thought all the way through, you might not get that special sticker from the government saying that yes, this is secure design, which means that you won't be able to sell into the government. Certain companies won't use your product. So there's actually a whole flow-on process from this that's coming through the pipeline.
Yeah. So Ben, I mean, that's a very interesting point. You talked about the government getting involved in this process. And of course, I mean, there are safety certification bodies for products, but software has never been a focus. But recently, I'm sure you would also have seen this guideline which was issued by NIST and the US government, where they have said that it is the responsibility of the AI provider to check and ensure that people who use those models are not misusing it.
Mm-hmm.
Right. So I mean, we have the European Union, which has published their AI laws, and I think other countries are also exploring as to how they would start regulating. So the moment they start regulating AI, I have a feeling that everything else also would get regulated, especially with respect to software. So
Sorry.
my thought is that people shouldn't be waiting till that happens, but start thinking about secure by design right at the outset. Before you conceptualize or during the conceptualization, look at the safety needs and ensure it is built into the product design. If at that point in time, you spoke about, root cause analysis, risk assessment, and if at that point in time, the design team feels that, that it is not going to be a viable proposition, then they probably may have to look at alternatives to get their products into the market. Ben, your thoughts?
Well, I think one of the biggest drivers that's going to come along, and this actually relates back to safety by design and the safety engineering process, is that, and luckily, when it comes to cybersecurity, we haven't had any, when we hear on the news, it'll be, because, someone couldn't check out their eBay purchase, or it's an inconvenience, or it could be quite severe. Someone has their Bitcoin wallets drained, or bank account details gets lost, taken, or personal information. But you don't hear about actual physical harm to people.
Absolutely.
Yeah, but I'm predicting something here, but I think you'll find that this will become an issue, and we'll in cybersecurity will suffer the same issues that need to be addressed in software engineering when it comes to harm, and that's you may start getting cyber instances where it was how many people were hurt, what was the fatalities. This is when it starts to become very serious. It's something that then companies or developers can't ignore. Just the way safety can't be ignored. You can't ignore safety. It's actually a lot of stuff can have criminal repercussions to it. So actually this is where cybersecurity can learn from software engineering. We can go like, well, what can we do to also make our software safe? And security is part of that. So this is where I guess now we get this sort of synergy between these two different areas, and we can learn a lot, both from engineering, safety, into our cybersecurity. And we should be doing that now, and that's why we should be doing it. And at a moral aspect, this is not necessarily I guess a lot of cybersecurity things don't get implemented because they go, oh, well, there's a particular cost that we can take, or we can generally write this off, or no, it might not be great with our competitors. But as you can see in engineering processes, when lives are lost, whole companies can fold. So this becomes very important, and this is where I think that we need to follow the engineering process into cybersecurity, and that's where we meet. And this is what needs to be to drive it forward. We need to be proactive about human life.
Absolutely. We need to be proactive, but what I'm also seeing, Ben, I'm sure you're also seeing in your part of the world, is that the regulators are now demanding that the companies disclose the breaches. But having said that, they're not being very specific. They're ambiguous. Right? So a lot of time, people tend to think that core IT systems are part of this reporting process, and anything other than that, especially industrial systems, are never in the focus. So we are talking about Internet of Things, operations technology, all put together, we are talking about industrial systems. And several organizations are dependent on this in very subtle ways. Now, for example, we use CCTV cameras. It may not be the mainstream IT service, but it is a service which you use to ensure your physical security borders are safe and secure. So I guess people will have to start thinking this through and build a framework. So Ben, I mean, in closing, I'd like to hear from you. What are one or two things you would want people to start thinking about or acting on?
Sure. So I guess, and yeah, you're very much right. And often a lot of companies and even government regulations, they're only interested about reporting when personal PII information's being lost. For most other things, the government seem to sort of not be so interested because I guess this is a public thing. Yet again, engineering, when something happens, it is amazing how much coverage can happen on a engineered problem happening. Whether it be a Tesla car that crashes or something, or or particularly aircraft faults or shipping faults going into bridges. so in engineering, you'll have these huge investigations, and some of it may end up going to court. In IT areas, yet again, this is something that's cybersecurity needs to get ready for, because we are having these smart cities. We are having all these devices that are being put in play that have huge impacts on people. It's this isn't exactly related to cybersecurity directly, but there was an instance where we had a failure from a network advertisement into our Optus network, which took out our emergency dialing numbers for several hours for lots of people. Luckily, no one died during the process when that happened, but that was a huge problem. If that was a malicious hack attack, where we all know Optus has had that problem before. The flow-on effects that could be really, really serious. And cybersecurity and IT systems have a direct relation with a lot of engineered IoT systems or internet-enabled industrial systems too, where we can have a cascade of failures. Some piece of malware or a threat actor can do something on one system, and maybe because on the engineering end, they hadn't considered that, because most engineering safety things are thinking, well, if you have a control room, if the control room loses power, will everything that's connected to just fail correctly? But in a, let's say, a malware or a threat actor attack, that control room may not just get all shut down, it will start working incorrectly. And how do those devices then deal with that information? Do all the traffic lights all turn green on all intersections at once? So
That is again the the Die Hard 4.
yeah, that's right. Maybe they're already ahead of it.
Yeah, they're ahead of it. Yes, absolutely.
So I think the takeaway is that cybersecurity is we need to really secure things. Human life will become important for us. We need to embrace our engineering software developing friends and others and be good allies. We need to be educational. We need to, essentially, look at system excellence. We need to bring it all together and help with all this, safety, and be proactive, whether it's be technical, whether it be academic, and whether it be political. We need to get out there and be right, and be protecting society, because cybersecurity people, we can be heroes too.
Absolutely. So Ben, I'm glad I had this conversation with you. Right? It's very, very rarely I see people talking about engineering and cybersecurity. Right? It's if a conversation actually happens, they're more focused on software security vulnerabilities, right? Or they would probably shift the conversation to CSVs, whatever was being published, vulnerability assessment, penetration testing, or maybe even they would talk about red teaming, blue teaming, purple teaming, and the list goes on. We've been also having this challenge, communicating in a language which the board understands cybersecurity. Now, having had this conversation, I now see that there has to be an ecosystem and a language which is easily understood by both the software engineers and the engineers. Well, both of them call themselves engineers, but their focus tends to be different, where engineers typically think about safety, whereas the software engineers typically think of bringing value and making it work. Safety is never a priority. So with that thought, my view is that we need to start thinking around design. When we design, we need to bring security into the core conversation. Look at if any of these security parameters fail, how it would impact. Not necessarily because, as you rightly said, most of the time when there's a software failure, people, when they lose money, we talk about the emotional quotient. That's it. There's a legal case, somebody's taken to courts, and then, sometimes they are let out after 2-3 years. Nothing gets done beyond that. But if an engineering product fails and it impacts the safety of humans, then that's a huge discussion. There's a lot of conversation which happens around trying to find out how not to have the same problem in the future. So there's a lot of study which goes into what went wrong so that the corrective actions can be put in place. It could be legislations, it could be guidelines, it could be training. There are a whole lot of things which actually come into play. So I'm hoping, I remember making a similar statement almost about 10 years ago, approximately 10 years ago, that someday software industry should be regulated. So with that thought, Ben, thank you so much for your insights. I gained a lot. It was very refreshing, and I'm sure those who are going to be watching this fireside chat will be immensely benefited by this. Thank you so much, Ben. Have a great day.
Thank you very much.